In this video, we will have a look at the difference between synchronous and asynchronous actions. In simple words, when you execute something synchronously, you need to wait until it finishes executing before moving on to another task. When you execute something asynchronously, you can move on to another task even before it finishes executing. Let's see how it looks on the diagrams. First, let's understand how synchronous actions work. The vertical line on the left represents the flow of the code. We have 4 statements here. The second statement represents the invocation of a normal synchronous function. Note how statements 3 and 4 are waiting until the function in statement 2 finishes its execution. The order of execution in this case is the following. First, statement 1 executes. Second, statement 2 invokes our synchronous function and all other statements wait until it finishes. Then, statements 3 and 4 execute. This is so-called blocking call. Nothing else can be executed until our function is done. If the function takes 1 hour to execute, all other statements will wait for 1 hour. Let's have a look at an example with 4 numbers from the previous video. We are interested in print2 function. Inside this function, we have defined another function which is called getNumber2. This function is completely normal and therefore synchronous. We are invoking getNumber2 function on line 11. Since getNumber2 function is synchronous, this line here will wait until getNumber function finishes executing. This is an example of blocking call. Let's go back to our diagrams and have a look at asynchronous actions. We have the same 4 statements here, but now the second statement represents the invocation of an asynchronous function. Unlike in the previous example, this call is non-blocking. You see, statements 3 and 4 don't wait until that function finishes executing. They can execute before that. The only thing they are waiting for is until asynchronous functions starts executing, but not until it finishes. The order of execution in this case is the following. First, statement 1 executes. Second, statement 2 invokes an asynchronous function and passes a callback to it. Then, statements 3 and 4 execute. After all synchronous statements in the code on the left have finished their execution, our asynchronous function invokes the callback that we have passed to it earlier. Now, if the function takes 1 hour to execute, all other statements will be executed immediately after the function starts, and then after 1 hour, the callback will get executed. Typical examples of asynchronous actions in JavaScript would be setTimeout, HTTP request, reading data from files, interacting with a database, etc. By the way, did you notice on the diagram how callback gets executed after all other synchronous statements are finished? Let's go back to our example with 4 numbers and have a look at print3 function. This is our print3 function. On line 18, we are invoking a fast.read file. As we already know, reading from file is an asynchronous action in JavaScript. Therefore, this is a non-blocking code, and if we had something after this call, for example here, something like console log, then it would be executed right away. Since we don't have any other statement inside print3 function, this function will return immediately. And this is actually the only asynchronous action in this code. All other actions are synchronous. Therefore, this is the order in which all the numbers will be printed to the console. First, number 1 will be printed, then number 2. Then readFile function will be invoked from inside the print3 function. Since it is an asynchronous function, print3 function will return immediately without waiting until the data will be actually read from that file. Then number 4 will be printed to the console. And after all synchronous code has finished executing, our callback will get executed. And this will print number 3 to the console. This is why we are getting the wrong order of numbers in this example. So in this video we have seen the difference between synchronous and asynchronous actions.